Assalamu alaikum. My name is Abdur Rauf, and today we are going to learn how to derive the famous equations of motion. As you know, there are three equations of motion. The first equation of motion is Vf equals Vi plus At. This is also written in some books as V equals U plus At. The second equation of motion is Vi plus half At square, and the third equation of motion is Vf square minus Vi square. In this video, we are going to learn how to derive the first equation of motion, and we will upload two more videos in which we will derive second equation of motion and third equation of motion. So you need to remain tuned, and you need to subscribe and press the notification icon that you can receive all the upcoming videos ahead. The first equation of motion, Vf equals Vi plus At. Now, as we see, there are few parameters that we can calculate using equations of motion, like initial velocity. The initial velocity can be represented with the symbol of U as well as with Vi. The final velocity is represented with the symbol of V or Vf. T represent the time interval during which the velocity changes. S represent the distance or displacement, and most importantly, A represent the uniform acceleration. These equations of motion are also called as equations of uniform acceleration motion. Before starting to derive the first equation of motion, we need to recall a few very important questions. Number one, what is meant by acceleration? Number two, when can acceleration be zero? And my third question is, when can acceleration be uniform? You can pause the video, write the answers, and then resume. The answer to the first question is acceleration is the change in velocity per unit time. This is how we define acceleration. The formula for acceleration is A equals Vf minus Vi by delta t, or it can also be written as A equals V minus U by delta t. Remember the fact that Vf or V represent the final velocity, Vi or U represent initial velocity, whereas delta t represent the time interval. The unit for acceleration is meter per second squared. Acceleration can be zero if a body is at rest. Yeah, if a body is absolutely at rest, you can say that acceleration is zero. Or if the body is moving with uniform velocity. We've learned that acceleration is change in velocity per unit time. So if there is no change in velocity, then you can say that acceleration is zero. Acceleration can be uniform if velocity of a body is increasing uniformly or decreasing uniformly. So if you want to see whether the acceleration is uniform or constant, now importantly, if the velocity is increasing uniformly, that means in each second the amount of increase in velocity is same, or the same happens like in decrease. So then we can say that acceleration is uniform. You can also say acceleration is constant. Now we are going to link these questions to the first equation, or particularly to all these three equations of motion. It is very important to know that these equations of motion can only be applied if the velocity of the object increases uniformly, or you can say acceleration is zero. It can be applied if acceleration is uniform or constant, but remember, you cannot apply these equations of motion if the acceleration of the body is changing. Deriving the first equation of motion, Vf equals Vi plus At. This can also be written as V equals U plus At, as I said earlier in different books. Let's consider a situation in which object starts from rest with initial velocity Vi, attains final velocity Vf in time t. Now, to calculate the acceleration of the body, we need to find the gradient of velocity time graph. We can also write the gradient of speed time graph. Consider this graph. We can see that from A to B, the line is showing a certain slope or gradient. If we calculate the gradient of this line, we will be able to get the acceleration. But hold on, before that, we need to know what is gradient, by the way. So, what is meant by gradient? What is the other name for gradient? State the formula for gradient. And what do we get by calculating the gradient of speed time graph? Now, gradient is a ratio by which you can compare the change in vertical axis with respect to change in horizontal axis. And normally we call the vertical axis as a y-axis and the horizontal axis as x-axis. Now we see how much change occur in y-axis when there was certain change in the x-axis. The other name for gradient is slope. As we said in the graph, it was shown a line from A to B. It was showing a certain slope. Slope is the English meaning of gradient. The formula for gradient, now that would be y2 minus y1 divided by x2 minus x1, or you can say change in y-axis with respect to change in x-axis. We get acceleration by taking the gradient of the speed time graph. So we get acceleration by taking gradient of the speed time graph, or you can use the word velocity time graph. We need to draw a horizontal line from A to C to show that the gradient or the slope of the line AB started from point A up to point B. Using the concept of gradient as change in y-axis, so we can write the line from C to B divided by change in x-axis, that would mean the line from C to A. So acceleration become A equal CB divided by CA. Now CA represent time, as this is parallel to time axis, so we can replace CA by small t. Hence the equation become A equal CB by t, or making CB as subject, so it becomes CB equal A multiplied by t. Now consider the line BD. As you see, if we exclude the portion from C to D, this portion, then the remaining length will be left as BC. So we can write that length of BC or CB is equal to length of BD minus length of CD. For example, the total length of the line BD is 6 centimeter. If you extract the portion of CD, for example, that is 2 centimeter, then the remaining length will be left as 4 centimeter. So here we are saying that the total line BD, now we are going to break it as the CB will be equals to BD minus CD. Consider the equation CB equals AT. Now we are going to substitute the CB and put BD minus CD in place of CB in this equation. So the equation will be now in this shape. Now what is BD? BD represent VF, means the final velocity. And what is CD? If you look at CD, this is equal and parallel to OA. And what does OA represent? It represent VI. So we can say that CD also represent VI. Hence, we can say that OA equals CD, which is equal to VI. So we can replace the term CD by VI, and we can replace the term BD by VF. So replacing the two terms, we get VF minus VI equals 80. Now we need to change the side of VI. When it changes the side, it becomes positive. So the equation will be rearranged, and it is now VF equals VI plus 80. So this is the first equation of motion. It can also be written as V equals U plus AT, or VF equals to VI plus AT. Alright students, hope this video was helpful, and you need to subscribe the channel and also press the bell icon, because we are going to upload the remaining two videos soon, and you will be able to get the notifications in time, and to understand and to learn the second and third equations of motion as well.